Today's lesson is from Chapter 1, Section 5. You'll find it on pages 29 through 31. Many careers require knowledge of geometry. Architecture, as well as landscape and industrial design, are just a few of those careers. People who work at these jobs usually make rough sketches to begin their new designs. Then they use drafting tools to make technical drawings of their plans. Today, you will learn to use some basic geometry tools to take measurements. You will also learn about systems of measurement, precision of measurement, absolute error and tolerance, and precision versus accuracy. As you study geometry, you will use some of these basic tools. The first tool is a straight edge. A straight edge is an object used to draw a straight line. A credit card, a piece of cardboard, or a ruler can serve as a straight edge. A straight edge is also used to check if a line is straight. Turn to page 29 in your book to answer the next two questions. Do not put a straight edge on the computer screen. Determine whether the sides of the triangle are straight. Place a straight edge along each side of the triangle. You can see that the sides are straight. This time, use a straight edge to determine which of the three segments at the upper left forms a straight line with the segment at the lower right. Could you tell that the top segment is the one that forms the straight line? A compass is another useful tool. A common use for a compass is drawing arcs and circles. An arc is part of a circle. The figures shown here are two different types of compasses. The A-shaped compass usually has a point and a pencil or lead point. The two legs of the compass are on a hinge so that they can be adjusted for different settings. This kind of compass is often used by engineers and cartographers, people who draw maps. One use of a compass is to compare lengths of segments. Turn to page 30 in your book to answer the next two problems. Do not put the compass on the computer screen. Use a compass to determine which segment is longer, segment AB or CD. Place the point of the compass on B and adjust the compass so that the pencil lies on the point A. Without changing the setting of your compass, now place the point of the compass on C. The pencil does not reach point D. Therefore, the segment CD is longer than the segment AB. Try this one. Which is longer, the segment from A to B or the segment from B to D? Again, try it in your book. You should have determined that the segments are the same length. In geometry, you will draw figures using only a compass and a straight edge. These drawings are called constructions. On a piece of paper, use your compass and straight edge to construct a six-sided figure. First, use your compass to draw a circle. Then use the same compass setting, put the point on the circle, and draw a small arc on the circle. Then move the compass point to the arc and draw another arc along the circle. Continue doing this until there are 6 arcs. Then use a straight edge to connect the points in order. If you need to pause the podcast right here and complete your construction, go ahead and do that and resume playing it when you're ready. Let's use a straight edge or compass to answer each of these questions. Use the practice worksheet that accompanies this lesson and answer the following questions. Again, do not attempt to use a straight edge or compass on your computer screen. Pause the lesson until you've completed your measurement on each problem. Then hit play to see if you got the correct answer. Which segment did you determine to be the longest here? The answer is G. Which of the three segments at the upper right formed the straight line with the segment at the lower left? You should have gotten line segment B. Does the inner arc or the outer arc on the right side of the segments go with the arc on the left side to form part of a circle? The outer arc is the correct answer. Is C the midpoint of AB? The midpoint of a segment is the point that is exactly in the middle. No, if C was the midpoint, the segment AC and the segment CB would have had the same measurement. If the circle with center C is drawn completely, will point X lie on the circle? No, you should have seen that it will lie inside the circle. If extended, will the segment VX intersect the segment ZY at Y? No, points V, X, and Y are not collinear. We've been using our tools to make measurements. Let's learn a little more about measurement. Measurements are composed of two parts. The first is the measure. The second is the unit of measure. The measure of a segment gives the number of units. The measurement of a segment is also called the length of the segment. The unit of measure will be in one of two systems, either the metric system, which is used in much of the world, or the customary system that we use in the US. We need to know how to convert from one system to the other. You've studied the metric system before. Here's a chart that shows you the most common conversions. These charts can be found on the internet and in many of your math books. You should be familiar with a lot of these conversions. Here's a list of prefixes for the metric system that you should know. Kilo, hecto, deca, deci, centa, milli, and micro. They attach to gram, liter, or meter. Do you know the acronym that helps you remember the first letter of these prefixes? King Henry died drinking chocolate milk Monday. Hope that can help you remember them. Now that we've discussed the unit of measure, we need to discuss a few more terms that deal with measurement. The first one is the word precision. The precision of a measurement depends on the smallest unit used to make a measurement. So a measurement in millimeters is more precise than a measurement in centimeters, because millimeters are smaller than centimeters. And the more digits behind the decimal point, the more precise the measurement. So a measurement of 129.7 millimeters is more precise than 130 millimeters. Look at page 58 in your book. The metric ruler shown gives a measurement that has 10 divisions per centimeter, so it measures with a precision of 1 millimeter. The customary ruler is marked with 16 divisions per inch, so it has a precision of 1/16 of an inch. You might see a problem like this on the proficiency exam. Let's try it. Tara takes 4 different measurements of the length of her calculator. Tara's 4 measurements are listed below. 14.8 centimeters, 15 centimeters, 148.6 millimeters, or 149 millimeters. Which measurement is the most precise? Again, we're looking for the smallest unit of measurement and the most number of digits behind the decimal point. So C is the correct answer, because millimeter is a smaller unit than centimeter, and there is 1 unit behind the decimal in answer C, none in answer D. The greatest possible error that you can make in any measurement is going to be half the smallest unit that you used to make the measurement with. So the greatest possible error of a measurement made with the precision of 1 millimeter would be half a millimeter. The greatest possible error for a measurement made with precision of 1/16 of an inch is 1/2 of 1/16, or 1/32 of an inch. This translates to 0.03125 as a decimal. Another term you might use instead is absolute error. The absolute error of a measurement is defined to be 1/2 the smallest unit used in making the measurement. For example, this drawing shows the distance between the centers of the two holes in a piece of metal. If the distance were measured to the nearest 1/4 of an inch, the absolute error would be 1/8 of an inch, which is half of a quarter. The symbol plus or minus is often used to report measurements. This way of reporting measurements helps to show how accurate the measurement is. The actual measurement will lie somewhere in this interval. It will be between 2 5/8 of an inch and 2 7/8 of an inch. Let's try writing some measurements. Write each reported measurement using an interval. Use M to represent the actual measurement. How would we write 25,000 plus or minus 500 voters? On the lower end, we would have 24,500 voters. On the upper end, we would have 25,500 voters. How would we write 15 plus or minus 0.5 kilograms? Again, we're going to subtract 0.5 from 15 for our lower end measurement. We're going to add 0.5 to 15 for our upper end measurement. So it would be written this way. 14.5 kilograms is less than our measurement, which is less than 15.5 kilograms. 750 plus or minus 25 customers could be written as 725 customers, which is less than our measurement, which is less than 775 customers. Again, we've added 25 to 750 for the upper end limit, and we've subtracted 25 from 750 for our lower end. 75 plus or minus 5 miles could be written as 70 miles, which is less than the measurement, which is less than 80 miles. How would you write 14 plus or minus 1/2 of a gallon? It would be 13.5 gallons, less than the measurement, which is less than 14.5 gallons. Subtract on the lower end, add on the upper end. 7 1/4 plus or minus 1/4 inches would be written as 7 inches, less than M, less than 7.5 inches. Subtract on the lower, add on the upper. Another problem you might see on the proficiency has to do with tolerance. Due to human and mechanical error, products that are made vary in their measurement. Have you ever noticed that some potato chip bags seem fuller than others? Each company decides how much difference they will tolerate. They give their employees the exact number they would like to see the product measure, and they also give them the amount of difference that they will tolerate or allow on either end. A potato chip bag should weigh 28.3 grams. If the tolerance is 1/10 of a gram, then I could add 1/10 to 28.3, and the bag might weigh 28.4 grams and be acceptable. Or I can subtract 1/10 from 28.3, and the bag could weigh 28.2 grams and still be acceptable or tolerated. The tolerance of a product is written in much the same way as the measurement with absolute error. The tolerable weight of the potato chip bag would be 28.2 grams, less than the measurement, less than 28.4 grams. When written this way, I would know that the weight of the bag should be 28.3 grams, but it could be plus or minus 1/10 of a gram. Try this sample proficiency question. The diameter of each tire produced by a factory is measured in inches. Each diameter must be within the range shown below. What is the tolerance range of the diameter of a tire produced by this factory? Here's a hint. X, the number in the middle, will be the average of the other two numbers that are given. Remember, average means to add those two numbers together and divide them by 2. So the average of the two numbers should have been 30.015. Now, looking at my options here, if I add 0.005 to that number, I get 30.020. If I subtract 0.005, I get 30.010. So A is the correct answer. The word precision can also mean consistency. Sometimes people confuse the word precision with the word accuracy. Precision and accuracy mean two different things. Accuracy is how close a measured value is to the actual or true value. This target shows us high accuracy. All of the points are very close to the red middle target, but it shows us low precision. They are not close to each other. This picture shows us precision. Precision is how close the measured values are to each other. None of the dots are very close to the red target, so none of them are accurate, but they're very close to each other. They're very consistent. So we have a target that shows precision. This target shows us both high accuracy, all of the points lie within the red target range. It also shows us high precision. They all lie very close to each other. So, if you're playing soccer and you always hit the left goal post instead of scoring, then you are not accurate, but you are precise. That was a lot of material to cover. Good job making it through to the end. Your homework for today is in your book, pages 33 and 34, problems 4 through 11.